Hi, I'm Lars. Welcome back to my workshop. Today I want to talk about, in this video, I'd like to talk about different types of electrical tools that you may need if you're going to do any electrical work. This is kind of part of the How to Tools Work electrical series that I'm putting together. Little things like, different size screwdrivers and why you would need them. Okay, so everyone thinks that screwdrivers are all built the same. These two obviously are not as wide as each other. Okay, you can literally put this one inside of this one. You need a big screwdriver because the screws on the side of outlets and the grounding screw are pretty wide. So you need a screwdriver that will at least span across this. If you were to use a smaller screwdriver, it would work, but these are not made of the toughest material, especially these guys. And if you get them when you're cranking them down because you really want them to be tight, you could literally just start carving up the screw. All right, so a wider screwdriver will help you with that. So two different size screwdrivers. You may need a really tiny screwdriver just for things that you need to poke at and whatever, just to be able to get to stuff. And obviously you need a Phillips head. Every outlet, light switch, whatever, they're all going to have Phillips heads that you're going to need something to be able to get into, turn on. Those are your screwdrivers. I highly recommend getting an impact drill if you're going to do this a lot, and a Phillips head bit for it, or any kind of drill, or electric screw gun, or anything to that effect. And the reason behind that is these screws are really long and they take a lot to get out, and doing this a lot, if you're doing a lot of outlets in your house or whatever, it's gonna wear on your wrist eventually. You need a utility knife. Why do you need a utility knife? Because when you're cutting wire, not like cutting wire off, but when you're trying to take out the sheathing, you're gonna cut this at an angle on each side and then rock it back and forth and break it off. Let me see if I have something here that can show it to you. So here's the sheeting on a wire, and if I just kind of put a little angle mark on it just to crack the sheathing, and you go on the other side and you do the same thing, you're not cutting the wires inside, and then all you do is just bend this back and forth a bunch and it will break. Okay, you're barely cutting through this paper, you're not marking the wire underneath at all. That's why you're doing it at about a 45-degree angle. And then when you insert these into boxes, you leave this on, slide it into the box, and then pull it off. Okay, there's this whole series I did on building this guy right here. There's a video on it, on that build, and I explain all that in there, so please watch it. You may need a stud finder if you're putting in anything that is pre-existing work, like you need to put a box in, in drywall. You don't want to be cutting your drywall up and all of a sudden run into a stud. It's terrible. You probably need a pencil. You're going to need a level, little level, because you want to be able to level your box where you're cutting that in. Wire strippers. These are vice grip. These are unique. They have all of the different sizes of wire, and they also have a pair of needle nose at the top. You also have some things for doing crimping, which are good. Crimping would be if you're crimping one of these crimps for like grounding wires and stuff. You can get them into the back of this and actually put a crimp in like that. Let's see that. I have a pair of Journeyman pliers. I love these things. I've had these things for like 20 years. These will cut big wire, they'll grab a hold of wire, and they also have a crimp tool built into them too. So I love my Journeyman pliers. Needle nose. If you've got a pair of these, you really don't need a pair of needle nose, but if you don't have a pair of these, you just have a regular pair of strippers, you're going to need a pair of needle nose. Because you need to put little curls on the end of a wire like this, and this is 12 gauge wire, and you cannot bend this with your fingers. Now if it's 14 gauge you probably can, but when you go to bend this, the needle nose makes it a lot easier to do. Also, if there's something in the box you need to get to, you can use them to pull stuff out. Side cutters. Side cutters, anytime you do any work in a box, if you need to cut a grounding wire or snip a wire in there to get the wire out, this is your best friend. All right, these rarely come out of my kit, but there are times where I need to get in and snip something, and this is not going to do it because the snipper's too far back. This is not going to do it because the snippers are too far back also. They're all the way down here. So these are side cutters. What else? Drills. So let me turn this this way. When you need to drill through a 2-by to put in new work stuff, you either need a 1/2 inch speed bore or you need a 3/4 inch speed bore. I usually buy the Irwin brand. They're a really great tool company. If you're only running 1 wire like I did here, 1/2 inch is fine. Okay, 1/2 inch will cover that wire really easily. Make sure if you ever do this that you're not binding this wire in there, and that if you're doing it through you're cutting between 2 floors. If you're going through the side here, you're pretty much okay. But if you're cutting between 2 floors, you need to fill this with foam or some sort of sealant to get in here. The reason is, if a fire starts in this box, this is going to be where it's going to get out, it's going to burn and burn this piece of wood. If this is sealed and a fire starts in here, not my thought, this is what I've heard from inspectors, this has a better chance of putting the fire out because once the oxygen burns up, it'll just die. If this is there, it's getting pure oxygen. It also keeps that fire from going a lot slower. It doesn't prevent it, but it does keep it from slowing down, going to burning to another story of the house, and helps the fireman out. If you have more than 1 wire, 3/4 inch is what you want to put in there. Honestly, if I was pushing 3-4 wires through a hole, I would be drilling a lot more holes. I don't know what code is. I really don't. I think it's by county, by state, by city, whatever. But if I had a bunch of wires coming up here, I would either put a conduit in or I would drill a whole bunch of holes for them, depending on what you need to do. But rarely is that ever the case. Personally, I've never seen it. I've never seen where you've got, an outlet that has 18 holes coming off it or 4 holes coming out of it. The reason is these boxes are defined by cubic inches, and I believe these boxes right here, if you look inside, this is 22 cubic inches. You can't see that because of the lighting, but it's up in the top and the back. There are a plethora of websites and everything else for looking up how many wires you can have coming in and coming out of a box. That all deals with the cubic inch of the box. All right, so I've got 1 wire coming in, right? Now, this is not 1 wire. This is actually 3. I don't know if the ground is counted, so it might be counted as 2, but this is also 3 wires. It might be counted as 2. So that's 4 lines coming in or 6 lines coming in, and they all take up so much space in this box for cubic inches. So please look this information up before you start doing any new work. Look at the NEC code book. Ask your county, ask your city, your inspectors, or whatever before you start doing any work on your house. All right. Again, I am not an electrician. Huge disclaimer on the beginning of every video I do about electricity. I'm not an electrician. I know about electric, and all this is me sharing my knowledge and my experiences. Some other things that you need is you need things to test your circuits. All right. To see, is there electricity in your circuit? If you don't have that, then you're going to have problems. Now, there's a couple different ones of these guys. There's this one here, which I recommend every homeowner needs, okay? It tells you, I don't know if I can get that focused in there or not, but when there's an open circuit, when there's an open neutral, when there's an open hot, or an open ground, neutral, hot, when you're hot and ground or reverse, when you're hot and neutral or reverse, or when everything's correct. The ideal is to have these 2 come up orange, like this. So I put this in there, see how they turn orange? That's what you want. You want both of them being orange. So this is a really something that I don't know if you really need it, but if you're doing a lot of electric work in your house, I recommend getting one because it's real easy to pop this thing out of your pocket and touch a wire, and it'll, I don't know if you can see that, it turns red when there's power on it, okay? And so if we put this up here in the light, see it turn red, I don't know if you can see that or not, and then when you turn it out, it goes back to green. So these are really nice to have. They have other tools like this, but this is kind of like the pocket version of it. They do have versions of this that are, they have big hoops on them, and you put them around something, it'll tell you that there's electricity moving through it. Another tool is this. Okay, again, if you're doing electricity and you think something's hot, you can put this in, and you can see it'll turn. I can get this in the outlet. It'll turn orange right here. I don't know if you can see the orange or not, but it'll turn orange and it will turn off. If you had this, if we had this taken apart and I didn't have a light bulb, I could put this up and touch it, flip it, and then this light would turn orange. So this is what this is mainly for. It's not really for checking stuff like that. That's why I say everyone should have one of these. All right. Okay, so another tool that you can use to figure out how many amps or volts rather, you can do this with amps too, but it's a little harder. How many volts that you have running through your circuit it's called a voltmeter or a multimeter. So with this one here, this is a Tenma. You can bring this up to the V with the little wave in it, means AC, and the ones with the little bars in it are DC, but you want to be on the AC. So I'm going to zoom this in so you can see this. Going to be on this side. Okay. So I think you can, there you go. So like right there, I think you can see that. So the one on the slot on the left is your ground, the other one is your positive, and you can see that this here is reading about, 121 volts. We're in America, so 121 is around correct. This is AC, okay? So AC has sine waves that go like this. All right. A lot of people call this 110, 115. It actually is 120. All right. And when you see one of these bigger guys, big plugs, usually you see these on your stoves, you see them on your dryers. These are for 240. Okay. So why are they at 240? There's two sine waves. Okay, so if anybody is trying to figure out, should I buy, if you have a router or something like for a CNC machine, I want to use a router, it's 115, it's what I have, it's great. Well, you're going to be running on one sine wave like this. I wish I had a pencil, I don't. But so one sine wave's going like this. When you're running 220 or 240, you have two sine waves. All right. So when this wave is going up and going down, as it's going down, there's another wave that's coming up. So there's a little bit of a gap here. Okay, so this wave's going up, this wave's going down. As this one's going down, this wave's going up. So there's just a little bridge where you're actually catching the alternating current. All right. Then there's something called three-phase current, three-phase circuitry, where you have three waves. And those waves just kind of bridge so that the high end and low end, they're just like very, very small little tiny waves, and the gap in between is not, it's just constant. I can get more into that in a later video because I do have to hook up some 220 and 110, and I can get all that kind of drilled out for you. But 220 will run motors smooth. Okay, this is why your dryer has a 220 in it. One, it's got to take a lot of energy to get that heat up, and the same thing with your stove, but it's a smoother run. It's not going like this continuously, and it doesn't burn out your motor. Okay, if you look at a lot of your motors, like on your table saws, your miter boxes, your drill presses, stuff like that, they're all gonna be 110, okay, or 120. One sine wave. Now, when you get into bigger things like CNC machines, and when you get into mills and big industry things, they're running on 220 because they don't want this thing to go like that with the electricity, all right? Think about a refrigerator when it kicks on and it has this immediately jump of current being pulled, and then it calms back down and drops down. So the immediate jump could be like 10 amps. When it calms back down, it may be pulling like an amp or 2 amps, not very that much. On big industry manufacturing motors and whatnot, they kick up and they'll stay at like 8 amps, like continuously. That gets hot, it gets wires hot, so 220 kind of calms all that down a little bit. All right, enough about that. So, if you're doing anything with wires, we don't really use tape, all right? You don't really use tape for anything to connect 2 wires together. So if I've got 2 wires that I need to connect together, take these 2 wires, since they're both the same color and you'd never connect anything else, well, you would. So if you're going to connect these 2 wires together, you're going to cross them like this, okay, and you're going to twist them up, and you're going to put a wire nut on it. Never ever put a wire nut on like this and just crank it down, okay? I don't care how much you crank this thing, right? Braid it a little bit, but watch this. They come apart really easy. If you have a set of big pliers like this, like Journeyman pliers, you cross them and then you twist them like this until those things are really, really tight. Now, try to pull that apart, it's going to be a lot more difficult. And then this is just nothing that. It's just a wire cap. And that's what they used to call them, wire caps, not wire nuts. Now, if I pull this back off, it doesn't loosen up. All right, you can snip the end of it, you can bend it over and do whatever you want with it. Now, about tape. Why do we have tape? I mean, this is all wire nuts. You've never really seen tape. And that kind of starts asking questions. Well, some tape, some wires, all right, you know, we got black and white. We know this runs current, this receives, you know, pulls current back out. But there are times when you're doing complex circuits where you need to connect a white wire to a black wire like that. And this is bringing in power. It just, trust me on this, it's just the way that it happens, all right? So you've got a white wire, you've got this black wire doing something else, and then you've got to connect this to here to get power. In that situation, you need to take a piece of tape out that's black, and you need to wrap this thing in black, all right? So that people know when it's coming into the circuit that this is the hot. When you start getting into stuff like this, okay, especially with the cost of wire nowadays, a lot of people are just buying 6-gauge wire or 10-gauge wire in bulk, and they're, instead of using an orange piece of wire, which is, you know, 6-gauge wire that you'd wire something like this up with, they're buying it in bulk, and you have to have a black branch or leg is what they call it, and a red leg, all right, because these take 4 wires. They take a ground, they take a black leg and a red leg, and then a neutral, all right? So this one here is only a 3-wire, but there are 4-wire ones. You need to take the red wire and you need to mark that red leg, all right? So, or you might have a white wire that you need to mark. So these last two at the back here, the green and the yellow, honestly, I don't think I've ever used those, but it's electrical tape. It's called electrical tape, and those are the 3 pieces of tape that I normally use. Something else you might need, and that's liquid electrical tape. This is black, all right, so as you can tell, it's black. But this comes in really, really handy if you accidentally nick a wire, Okay, so you nick the wire, you need to put some of this on it instead of putting tape on it. It dries, it becomes pretty hard, just about like this. So, other than that, you might need some nails. You got NM nail, cable nails, and you also have these things. To be honest with you, I'm not a huge fan of these. These are the little white ones. Reason is when you're putting nails in, you can hit the other one and they bend, but I still do use them for certain things. These are the ones that I really like. All right, and those are just to, as you can see here, tack your wire up. When you put them in, you hammer them in. You don't want to pinch that wire real tight. They're just there to hold the wire, nothing major. So that is all the tools that I think you will probably need in order to do any, if you're doing a big electrical kind of statement. I'll list all these in the description. And always a tape measure and a pencil. All right, those always come in handy. So if you liked the video, please click like, please subscribe to the channel, and I'll see you next time in the workshop.